Working with 5-axis terminology, Part 4, From and Towards a Curve. So firstly, let's look at a definition for programming from and towards a curve. From a curve is when the tip of the tool is constantly pointing away from a chosen curve as it follows the toolpath. In the first picture, you can see that as we strike a line from the tip of the tool up through the tool axis, that it would intersect with the chosen curve. In this case, the tool always points away from the curve. Programming towards a curve is the opposite. The tip of the tool is constantly pointing towards a chosen curve as it follows the toolpath. In the second picture, we strike a line from the tip of the tool towards the curve. You can see that as the tool tracks the toolpath, it is always pointing towards the chosen curve. So let's look at some programming examples of using from and towards a curve. I'll be using Autodesk PowerMill to show this example. So this is programming from and towards a curve. Firstly, let's look at programming from a curve. I have a toolpath here to program this cavity around the component here. And what we're using is a projection toolpath. And it's worth just saying a few things about this toolpath. This is a curve projection toolpath. And just like the 5-axis motion is being controlled by a curve, it's worth pointing out that this toolpath also is being driven by a curve. So this toolpath has been driven by curve feature 6-1. So let's have a look at that. That's a pattern here by this curve. So what's happening is that from that curve, if we preview that, from that curve we are projecting outwards and hitting all the surfaces that we can see as we project. And the result is the given toolpath. So from that curve, along the center of that cavity, we are projecting outwards. So that's curve projection. We've got a 1mm step over with a 5mm bore nose. Let's turn that preview frame off. And similarly to our other examples, if we were to program this just maintaining a vertical axis, by the time we got down to this kind of area here, if we didn't have tilt, as we went around the radius at the bottom, we would see that the holder would be colliding with the component edge. So what we're going to do is control the 5-axis motion of the tool to stop any collision taking place, and we're going to use a curve very similar to this curve to control the 5-axis motion that we desire. So let's have a look in the settings of this toolpath. So in this curve projection toolpath, under tool axis, we've asked PowerMill to use from a curve in our tool axis pull down window. And we're using curve feature 6, which is our first curve here, which really is a replica of the curve that we saw earlier that the toolpath is using to project from. But we've lifted this curve to control the type of angle that we want the tool to tilt at. So let's simulate that to see what that looks like. As this toolpath simulates, we'll see that the tool is being controlled from this curve. So you can see that as the tool moves up and down this feature, it is being controlled from this curve. So as it moves along the feature, the curve which strikes through and follows the center point of the curve of the feature will control the movement of that tool. So we can see that the tip of the tool is constantly pointing away from that curve. Hence, from a curve. So if we just speed that up, you can see that all the way through that cavity, that tool is being projected and controlled from that curve. This allows us again to keep a nice short assembly rather than having to extend the tool if we were to do this in a 3-axis motion. So that's from a curve. So let's have a look at programming towards a curve. Here we have a toolpath that is going to machine the outer profile. We will notice that the outer profile is not square, and it has curvature and undercut to it. As we look around each face, we'll see that there's curvature all the way around that profile. So to actually machine it, we need to have another projection type toolpath. So just to say a little bit about this projection toolpath, this is a line projection toolpath. As we look at the settings for this, we'll see that at x0 and y0, a position of minus 122 in the z, which positions us 2 millimeters below this surface. That's where we want to start projecting from. And then if we look at our pattern, from that 122 down, which is our 0 point here, we want to go another minus 50 and project inwardly. So as we draw the preview frame, we can see that from this height to 50 mm down, we're projecting inwardly, and that is so that we can access that undercut area, which we couldn't if we just projected, or if we just did a standard 3-axis toolpath from the Z view. So that's line projection. So let's just turn that preview frame off. So to control our 5-axis motion, in this case we're using towards a curve, because even though the toolpath is being projected, our tool needs to tip over away from the vertical to actually machine the feature. So under tool axis, we've chosen towards a curve, and this curve is feature 7, which is that pattern there. So I've created a pattern or a curve to replicate the kind of shape that I want the tool to follow as it produces and tracks this toolpath. So as it tracks this toolpath, we'll see when we simulate it that the tip of the tool will constantly point towards the curve that we've created. It will stay anchored to that curve. If we just draw the tool axis and turn that pattern off, the tool axis has been defined by the curve that we've chosen. So let's simulate that to see what that looks like. So as the tool tracks around that profile, we can see that it constantly points towards the curve. And again, this allows us to maintain a short assembly, a short standout length of the cutter, so that we can push the data because of extra rigidity in our assembly, whilst maintaining an excellent surface finish. So that tool constantly point towards the curve. And where this curve is good, rather than just using a standard lean, is that we can design that curve in a way that will benefit us and to how and where we want the tool to tilt at a given point around this component. For instance, we could change this curve, this arc on the curve, to make it greater or shallower, to give the tool a longer sweep of motion around this area here. And that just gives us some flexibility on how we want to control that 5-axis motion. So that's programming towards a curve. And that will finish off that profile all the way down, constantly pointing towards that curve. Okay, so if you're new to 5-axis and you're looking at understanding 5-axis terminology, I hope that's been useful to you. That's programming from and towards a curve.